Okay, so we're looking at the effective annual interest rate. Let me type it out here. This is your interest rate for the year after you account for compounding. Okay, colleagues? Your interest rate for the year after you account for compounding. Okay, so for example, if the interest rate is 10% and it's compounded semi-annually, okay, so if it's compounded semi-annually, we know that it's compounded twice in a year, okay, or you'll be paid interest twice in a year. Now you want to find out, okay, after we've accounted for the compounding, what is the interest that we received for that year? Okay, you want to find out what is the interest that we received for that year after we take into effect compounding. All right. So this is the formula for the effective annual interest rate. 1 plus the rate divided by m, which is the number of compoundings, to the power m minus 1. All right. So you're going to say 1 plus the interest rate is 10%. If it's compounded semi-annually, m equals 2 to the power 2 minus 1. So we're going to say 10% divided by 2, that is 5%. So you say 1 plus. So 5%, we'll just convert it into a decimal, okay, colleagues? If we wanted even this 10%, let's put it as a decimal to make life easy. 10% as a decimal is 0.1. So 0.1 divided by 2, it's 0.05, which is just the same as 5%, to the power 2 minus 1. Okay, so I'm going to say 1.05 to the power 2 minus 1. Colleagues, those with the calculator, 1.05 to the power 2. 1.1025 1.1025 minus 1. Yes, which is equal to 10.25%. So this is your interest rate for the year after you've taken the effects of compounding. Remember, we said the interest rate is 10% compounded semi-annually. So if you want to say, okay, after a year passes, what is the interest that I've earned? It's 10.25%. Any questions? Now, the second part that I need to introduce is that this effective annual interest rate, apart from it giving you your interest rate for the year after you have taken into account compounding, it also helps you match the compounding period with the payment period for annuities. Okay, it helps you match the compounding period for the payment period. This is what I mean. For example, the interest rate is 10% compounded semi-annually, right? And for this annuity, you're paid after a year, okay? Your yearly payments of maybe let's say 100,000 kwaj. So here the compounding period is semi-annual, it's twice a year. But the payment is only once a year. Okay, so you need to get the effective annual interest rate so that you can match the compounding period, convert it from semi-annually to yearly, so that it matches with the payment period. I repeat, the effective annual interest rate helps you match the compounding period with the payment period. So if the payment period is after a year, but the compounding period is semi-annually, every after 6 months, you need to match them before you get the present value. And in order to match them, you need to get the effective annual interest rate. All right. So for this same one, if these yearly payments are 100,000 for 4 years, okay, and they are asking you find the present value of this annuity. So the first thing you need to do is you need to match the compounding period to the payment period. The payment period is after a year. The compounding period is 6 months. For semi-annually is twice a year. So twice a year is broken down into 6 months. So you need to first get the effective annual interest rate so that this compounding period converts from 6 months to a year. Uh-huh. Yes. Is that a question? Or is it a hand raised? You can ask colleagues. Feel free to ask whatever. Okay. So as I said, the compounding period is 6 months. Since it's semi-annually, so it's meant after 6 months, then after another 6 months. So we need to match the compounding period and the payment period. So you first get the effective annual interest rate. Okay. So we saw the effective annual interest rate for this 10%, which is compounded semi-annually. We say the effective annual interest rate is 10.2.5% because we say this is the interest you get after a year. All right. So now once you matched the compounding period and the payment period, you can now get the present value for your annuity. Okay, and remember the formula for the present value of annuity: PV equals CF one minus one over one plus R to the power N over R. So take note of this. If in the question the compounding period and the payment period are the same, you don't need to get the effective annual interest rate. Okay? Take note. If in the question the compounding period and the payment period are the same, no need for the effective annual interest rate. But if the compounding period and the payment period are not matching, then you need to get the effective annual interest rate. Okay? So, in this case, the cash flow 100,000 over, open brackets, 1 minus 1 over 1 plus, okay, so we're going to, this R, we're going to use this one now, 10 to 5. That's what we're going to use, okay? So here there was no need to divide R by M or multiply T times M, okay, because we've equalized everything, okay? We've equalized everything, okay? So here, this will be, this R, we're using this effective annual interest rate, okay? So we're going to say 0.1025 to the power, they said 4 years, so we're going to use 4, okay, over 0.1025. Let's tabulate this column. Has anyone got a value? Let's see, 100,000, open brackets, 1, excuse me, 1 1.1025 to the power 4 over 0.125. Let me hear your answers. Seems there's someone trying to join. Mm-hmm. Okay, just repeat it. You went. The network was cutting for a small while. 317,229. Colleagues, what about the others? Let me also tabulate. I was doing something. Mm-hmm. Okay, finding 315. Okay. So maybe it's. Why are you rounding off? Okay, that's why maybe. Okay. Let me write that down. 315. Uh-huh. 121. Okay. Anybody else? Let me also do it here. 100,000. 1 divided by 14774. 1 divided by. Okay, so 1 divided by 1.4774. That is 0.676. 1 minus 0.676, that is 0.324. 0.324 divided by 0.1025, 0.16 times 100,000. Okay, I'm finding 316,000. I found in the middle here. 316,097. So it's just rounding off differences. Yes. So, colleagues, you only do this when in the question you have seen the compounding period and the payment period are not matching. As we saw in this example, the compounding period, they say it's compounded semi-annually, so it's compounding period 6 months. The payment is a yearly payment, so they were not matching. So we needed to match the compounding period and the payment period. That's why we got the effective annual interest rate. Okay, and then you just solve it like a normal annuity. Okay, no need to multiply 4 times the number of compoundings and r divided by the number of compoundings. No need to do that. because they've been equalized now here. Okay. It's like each year you're earning an interest of 10.25%. Okay. But if in the question the compounding period and the payment period are the same, then there's no need for this. That's why you now do n times number of compoundings and R divided by the number of compounding.